Algebra is an important topic to understand for GED math. In this final video in my GED Math Algebra series, I'm going to cover some important information that can help you improve your score on algebra questions. If you haven't seen part 1 yet and want to watch it, I'll put a link down below in the description where you can find it. Now let's get started. Which expression below is equivalent to 10a plus 3a squared plus 4 plus 15a minus 2? So now's your chance if you'd like to pause the video, try to figure this out. Is the answer A, B, C, or D? And whenever you're ready, we'll go over the answer. So the key here is that we have to combine the like terms. And if you're not sure what I mean by that, let me show you. So let's start by looking at this 10a. So we see that the first term here has the variable a. And if you're not sure what I mean by variable, variable is just what we call the letter here. So we see that the first term has an a. Now, do we see any other terms that just have an a? Well, we see that this 15a has an a in it. So I'm going to add 10a and 15a. So the way that I do that is I just add 10 and 15 and I bring the a along for the ride. So 10a plus 15a is 25a. Now, you might be wondering, how do I handle this 3a squared? Because 10a has an a and 3a squared also has an a. Well, we all have to realize that they have different exponents. So because they have different exponents, they aren't like terms. So I'm just going to leave the 3a squared as it is. Now the last thing I have to do is take care of the two numbers here that don't have a's with them. So we see this 4 and we see that we have a 2 here and it has a minus in front of it. So I do 4 minus 2, which is 2. So the answer here is D. It's just written with the terms in a different order, but D is the correct answer here. So your next example is on the screen. Let me give you a chance now if you'd like to pause the video, try to figure this out. And if you're not sure how to do it, absolutely no worries because we're just going to go over it. Okay, so the first step here is to take everything and rewrite it without the parentheses. So let me do that. Okay, so I have this written out now without the parentheses. And I know my handwriting is hard to read, so I do thank you for bearing with me. But basically, what I'm going to do now is combine the like terms. So the first thing I have here is 9b raised to the power of 3. And I have one other term raised to the power of 3, and that's this 14. So I'm going to do 9b raised to the power of 3 plus 14b to the power of 3. So how do I do that? Well, I just add 9 and 14, which is 23. And I bring that b raised to the power of 3 along for the ride. So now let me go to the next term. So I have this minus 16b, and I want to look and see if I have any other terms with just b's in them. And I do. I have this minus 4b. So negative 16 minus 4 is negative 20, and I want to bring that b along for the ride. So lastly, I want to look at my two numbers here, and these numbers don't have any letters with them. I've got 5 and 1, so I'm going to do 5 plus 1, and that is 6. So the correct answer here is A, 23b raised to the power of 3 minus 20b plus 6. So your next example is on the screen here. Let me give you a chance now if you'd like to try this out. You can pause the video and give it a shot, and if you get stuck or have any trouble with this, don't worry because we're just going to talk about it afterwards. So I'm going to start off here just by rewriting this without the parentheses, but there is a twist here that we have to be aware of. So maybe you saw this twist when you did the question, and maybe you didn't, but let me explain what the twist is. So the twist is that we have to take this minus sign, and we have to distribute it to everything in the second set of parentheses here. Okay, so if you're not sure what I mean by that, let me show you. So since we're distributing this minus sign, right, I'm going to write minus 3a squared, and this minus times another minus becomes a plus. So then I write plus 7a, and the same thing with my minus 2 here, right? So I take the minus sign and I distribute it, and since it's minus times minus, it becomes positive. So this becomes plus 2. Okay, so remember, a negative number times another negative is a positive. So that's the main idea here. So this is how it should be set up. Negative 12a squared minus 5a plus 1 minus 3a squared plus 7a plus 2. Okay, so now the last step here is to combine the like terms. So I see that my first term here has an a squared in it, and I also see that this negative 3 has an a squared in it. So what is negative 12 minus 3. Well, negative 12 minus 3 is negative 15, and I'm going to bring that a squared along for the ride. So now I come over here, I see that I've got minus 5a. And I also have this 7a right here. So what is minus 5a plus 7? Well, that's going to give us positive 2a. So lastly, I've got this 1 plus 2, and 1 plus 2 is 3. So when all is said and done, I should have negative 15a squared plus 2a plus 3, and that is answer C. So C is the correct answer here. So your next example is on the screen. Let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. And as always, don't worry if you have any trouble with this because we're just going to talk about it. So the key to getting this question right is to use the FOIL method. The F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So what I'm going to do here is I'm going to look at my first set of parentheses first here, and I'm going to take the first letter here, which is A, and I'm going to start by multiplying it by the first letter in the second set of parentheses. So in other words, I'm going to do A times X, which is just AX. So now let me do the two outermost terms. So in my first set of parentheses, I have my A, and I'm going to come over here and multiply A by Z. So I'm going to write plus AZ. So next I want to do the inner terms. So that would be my B and my X. All right, so I'm going to do B times X, which is BX. And last, I'm going to do B times Z. So I write plus BZ. Okay, so the answer here is AX plus AZ plus BX plus BZ. So A is the correct answer. So on the screen now is your next example. Let me give you a chance if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so the way we want to start this is by taking the first term in the first set of parentheses and taking the second term in the second set of parentheses, and we're going to multiply them. So what is 7a times a? 7a times a is 7a squared. So that takes care of the first. So now let's do the outer. So I'm going to take the 7a and I'm going to multiply it by negative 5. And I have to remember to take this negative sign or this minus sign, whatever you want to call it, into account here. So 7 times negative 5 is negative 35a. So basically what I'm doing is 7 times negative 5, and I'm just going to bring that a along for the ride. Okay, so that takes care of the outer. So now we have to do the inner. So the innermost terms are 8 and a. So 8 times a is just 8a. So I'm going to write plus 8a here. Okay, so now let's do the last. So the last would be 8 and negative 5. And again, we have to remember that this minus sign is here. So 8 times negative 5 is negative 40. So now we just combine the like terms and we're done. So I've got negative 35a plus 8a. That gives us negative 27a. So when all is said and done, we're going to have 7a squared minus 27a minus 40 as our answer. And that is answer choice A. So A is the correct answer here. So the next question is on the screen. Which of the following is equal to x squared plus 4x minus 12? And I've given you the standard form of a quadratic equation, y equals ax squared plus bx plus c. And this I took right off the formula sheet for the GED Math. And if you Google GED Math formula sheet, the first one that comes up, I think, from GED.com is the one that I'm using. And I pulled it right off of there for our practice purposes, just to save you some time, so you don't have to look it up for now. And I will put a link in the description to the exact version of the formula sheet I found. Again, I'm pretty sure I just Googled GED Math formula sheet, and it's the first one that popped up. But anyway, I will put a link to it down below. And let me give you a chance now to pause the video, try this out, and if you get stuck, don't worry because we're just going to go over it. And there are multiple ways to approach this question here, and I'll give you a chance to try it now. Okay, so the first thing that we want to see here is that we can solve this by factoring. And when I teach factoring, I like to draw an X, and the way I do this is I put a times c in the top of my X here, and then I put a b down here. And you might be wondering, why in the world would you do that? Well, let me show you. So the first thing that I want to do whenever I'm factoring is I'm going to multiply my a and my c. So if you're not sure, well, which one's a, which one's c, let me show you. So if we look at the standard form here, we see ax squared plus bx plus c. So I know that the number in front of my x squared is a. So what is the number in front of x squared? Well, we don't see a number written out, so we just assume it's 1. So my a is 1. And what's my c? Well, my c, if we look at the standard form, it's the last term. My c is negative 12. Okay, and it's very important to consider the minus in front of the 12 here, the minus sign in front of the 12. And so we're going to have 1 times negative 12. That's going to be my a times c. So what is 1 times negative 12? 1 times negative 12 is just negative 12. So I'm going to put that on top of my x. And so I'm going to write the b down here. And so what is the b? Well, from the standard form, we know that b is the number in front of the x. So b is 4. So I'm going to put a 4 down here. So you might be wondering, well, where in the world are you going with this? Well, let me tell you. The name of the game here is that we want to find two numbers that will multiply together to give us negative 12. But the catch is that the numbers have to add to give us positive 4. So a good way to start, in my opinion, when you're learning factoring is just by listing all of the pairs of numbers that you can think of that will multiply together to give us negative 12. So one would be negative 1 and 12. If you multiply them together, you get negative 12. We could also do 1 and negative 12. And then we could do 3 and negative 4. And we could do negative 3 and positive 4. And then there's also 2 and negative 6. And negative 2 and 6. So on your test, I'm not necessarily saying that you have to take the time to list out every single pair you can think of that will multiply together to give you negative 12. I just think that when you're first learning this, for practicing, in my opinion, I think it's helpful to start by learning how to do it this way. But on your test, you will just want to list pairs until you find a pair that will multiply together to give you negative 12 and also add up to 4. All right, so again, I'm not necessarily saying you have to take the time to write all these out on your test, but when we're first learning it, I think it's a helpful way to go about it, in my opinion. Up to you to decide how you want to do it on your test. But anyway, I see that all of these pairs will multiply together to give me negative 12. But the one that I see here that is the one I want to pick is this negative 2 and 6. So negative 2 times 6 is negative 12, but negative 2 plus 6 is positive 4. So this is the pair that I want to go with. All right, so what does this tell me? Well, what this tells me is that x squared plus 4x minus 12, we can rewrite it as x minus 2, x plus 6. All right, just like this. And so we see that the correct answer here is D. Now, another way to approach this could have been to take each pair here and use the FOIL method until you got back to this x squared plus 4x minus 12. All right, so for example, if you wanted to, you could take x minus 2 and x plus 6, and you could go through the FOIL method and work through it, and it would give you x squared plus 4x minus 12. Now, for the sake of time, I'm not going to show this right now, but just keep in mind that that is one way you could do this. It might take you some time, but you definitely could use the FOIL method on each answer choice until you got x squared plus 4x minus 12. Now, there's one more thing I want to point out here, though, that you might have seen. So if instead of doing the full FOIL method for each answer choice, one thing you could have done is started by doing the lasts here. So you could do 5 times negative 1 and see that that's negative 5. And then you could look over here and see that the C term is negative 12. So you would say, well, this can't be right. Same with B here, right? We could do negative 12 times 7. And since that doesn't give us negative 12, we could rule that out. And you could have looked at C and seen that 2 times negative 6 is negative 12. So C could be right. And you could have came to D and done negative 2 times 6 and seen that that gives you negative 12. So you could have narrowed it down to just these two, and then you could have maybe done the FOIL method on both of them to see which one gives you x squared plus 4x minus 12. So just something to keep in mind. So for this next question, you can solve it by factoring, and you can also use the quadratic formula. So first, I recommend trying to solve it by factoring. And then after we go over that, I'll give you a chance to try it with a quadratic formula, and I'll show you how to use it with the quadratic formula. But first, I recommend trying to solve it by factoring. And so on your test for a question like this, it'll be up to you to decide if you want to use factoring or if you want to use the quadratic formula. But it doesn't hurt to get some practice using both methods. So that's what I say for right now. Please try to solve this using factoring. And the question is, which of the following are solutions to the equation x squared minus x minus 2? So let me give you a chance now to pause the video. And if you have any trouble doing this or aren't sure how to do it, don't worry because we're just going to go over it. Okay, so let's start off by factoring here. So let me draw my x that I use when I teach factoring. And up here, I put a times c. And down here, I put my b. Okay, so when I look at this x squared minus x minus 2, what is my a? Well, my a is just 1, right? Because the a is the number in front of the x squared. And since we don't see a number here, I just assume it's 1. So what is my c? Well, remember, if we look at the standard form of a quadratic equation right here, and we see c, we come down here and we know that c is negative 2. And it's very important to remember to take this minus sign or this negative sign, whatever you want to call it, in front of the 2 into consideration. Okay, so my a times c is just negative 2. So let me put negative 2 right here. Now my b is the number in front of x. So we don't see a number in front of the x, so we just assume it's 1, but we also see this minus sign here, so we assume it's negative 1. So again, a times c is negative 2, and my b is negative 1. So what's my next step here? Well, my next step is to list out pairs of numbers that multiply together to give us negative 2, and then I'm going to look and see which pair adds to give me negative 1. So we could do 1 and negative 2, and these will multiply together to give us negative 2. And then there's also negative 1 and positive 2. All right, so these pairs multiply together to give us negative 2, but only one of them adds together to give us negative 1. So this pair right here, this 1 and negative 2, if we add them together, we get negative 1. So this is the pair that we want to use. Okay, but we're not done yet. So what we could do is write x plus 1, and we could write x minus 2. All right. So basically what I know now is that I can take this x squared minus x minus 2, and I can rewrite it as x plus 1 times x minus 2. And I could use the FOIL method here and get back to x squared minus x minus 2 if I wanted to. All right, but the name of the game here is we have to find the solutions to the equations. So what I want to do now is get this x plus 1 and set it equal to 0. So I have x plus 1 equals 0, and I want to get the x by itself. So how do I get the x by itself? Well, if I subtract 1 from both sides, I'll see that x equals negative 1. So one solution here is x equals negative 1. Now to get the other solution, I want to take this x minus 2, and I set x minus 2 equal to 0, and I want to solve for x. In other words, I want to get x by itself on one side of the equation. And the way I do that is by adding 2. So I add 2 to both sides, and what do I get? I get x equals positive 2. So B is the correct answer here. So which of the following are solutions to the equation x squared minus x minus 2? This time, let's have you try it if you want to using the quadratic formula. And again, on the test, if you get a question like this, it's up to you to decide if you want to use factoring or if you want to use the quadratic formula, but it doesn't hurt to get some practice using both methods. So let's have you pause the video if you'd like to and try this out, but this time, try to get the solutions using the quadratic formula. And if you're not sure how to do that, don't worry because I'm just going to go over it whenever you want to pause the video. So let me give you a chance to pause the video and try that now. Okay, so the quadratic formula, the key to getting questions right using it is really just putting the numbers into the formula the right way. And so we want to start with negative b. Okay, so we have negative b. So what's our b? Our b is negative 1. All right, so we've got negative times negative 1, which is positive 1. So I'm just going to put positive 1 here. So we have positive 1 plus or minus, and if you're not sure why it says plus or minus or how you handle that, don't worry because I'll explain it to you shortly. So we have 1 plus or minus the square root of b squared minus 4ac. So what is b squared? Well, we know that b is negative 1, and negative 1 squared is positive 1. So I'm just going to put 1 here for b squared. So I have 1 minus 4 times a times c. So what is my a? My a is 1. And what is my c? My c is negative 2. All right, and again, it's very important to consider the minus signs when we do this. That's a really easy mistake to make, is to overlook a minus sign like this and put in positive 2 here. All right, so just keep that in mind here. So now down here we have 2a. So 2 times 1 is just 2. So I'm just going to put 2 here. Okay, so now what is this here? This 1 minus 4 times 1 times negative 2. Well, negative 4 times 1 is still negative 4. Times negative 2 gives me positive 8. So when I rewrite this, I'll have 1 plus or minus the square root of 1 plus 8. And again, the reason it's plus 8 is because negative 4 times 1 is just negative 4, times negative 2 gives us positive 8. So I have this 1 plus or minus the square root of 1 plus 8 all over 2. All right, so I can rewrite this again now, and I'll have 1 plus or minus the square root of 9 all over 2. And I recommend using your calculator as much as you want and as much as you need to do the math here. And we'll see that the square root of 9 is 3. Okay, so the square root of 9 is 3. So I can rewrite this yet again as 1 plus or minus 3 all over 2. So now we're at the part that we want to get to here. So what I'm going to do first is I'm going to ignore the minus, and I'm going to do 1 plus 3 and divide that by 2. So what is 1 plus 3? 1 plus 3 is 4. And what is 4 divided by 2? Well, 4 divided by 2 is 2. So we know that one solution is x equals 2. All right, so now let's go back to this step. Let me delete this here so we can have some room to work here. So we know that x equals 2 is one solution, and let's go back to the step here. So remember, I did 1 plus 3 divided by 2. So this time, let's do 1 minus 3 and divide by 2. So what is 1 minus 3? 1 minus 3 is negative 2. And what is negative 2 divided by positive 2? Negative 2 divided by positive 2 is negative 1. So the other solution is x equals negative 1. Okay, so when all is said and done here, we know that B is the correct answer. The next question says, which of the following are solutions to the equation 2x squared minus 7x plus 6? And first, if you want to try this out, let's have you try it by factoring first if you'd like to. And then after we go over that, I'll have you try it using the quadratic formula if you'd like to, because it doesn't hurt to try both ways since we're just practicing for right now. So let me give you a chance. Like I said, please try to solve this by factoring first. So let me give you a chance to try that now. And if you're not sure how to do it, no worries whatsoever, because then we're just going to go over it. Okay, so let's go over how to do this by factoring first. So the first thing I want to do is multiply my a and c. So in 2x squared minus 7x plus 6, what's my a? Well, my a is 2, and my c is 6. So what is 2 times 6? 2 times 6 is positive 12. So now I'm going to put my b down here. So my b is negative 7. So I'm going to put negative 7 down here. So what's the name of the game now? The name of the game is to find two pairs of numbers that will multiply together to give me positive 12, but they have to add up to be negative 7. So the pairs of numbers that will multiply together to give us positive 12, we'd have positive 1 and positive 12, negative 1 and negative 12, and then we could do 2 and 6, and then also negative 2 and negative 6, and then there's 3 and 4, and then also negative 3 and negative 4. And it looks like if we add negative 3 and negative 4, we're going to end up with negative 7. So this is the pair that we want to pick here. So now what we can do is we can write x minus 3 and x minus 4. But there is a catch here, okay? So we're not done yet. So this time, this situation is a little different from the previous example because we have a 2 here. All right, we've got our 2 here in front of the x squared. So what I have to do is I have to come to both numbers here, and I have to divide by 2. So I'm going to do 3 divided by 2, and also this 4 here, I have to divide that by 2 as well. Okay, so now what I want to do is take this x minus 3 over 2 and set it equal to 0, and I want to solve this for x. So I add 3 over 2 to both sides, and I'll figure out that one solution is x equals 3 over 2. So now I want to do the same, this x minus 4 over 2, and since 4 over 2 is just 2, what I can do is I can write x minus 2 equals 0, and when I solve this for x, I'll see that x equals 2. So my two solutions here are x equals 2 and x equals 3 over 2, so A is the correct answer here. So this time, let's solve which of the following are solutions to the equation 2x squared minus 7x plus 6 using the quadratic formula. So this time, please try this if you'd like to using the quadratic formula. So let me give you a chance to pause the video, and let me give you a chance to try it using the quadratic formula. And if you get stuck or aren't sure how to do it, don't worry about it because we're just going to go over the answer. Okay, so let's go over this now. So the key to getting these questions right, in my opinion, is making sure you set it up and plug everything into the formula the correct way. And I would recommend using your calculator as much as you want to and as much as you feel you need to. So we're going to start here with negative b, or the opposite of b is another way to say that. So I have this negative sign in front of the b, and then my b is negative 7. So I'm going to have negative times negative 7, which becomes positive. So I'm going to start by just putting a 7 here. So I have positive 7 plus or minus the square root of b squared minus 4ac all over 2a. So what is b squared? Well, b is negative 7, and negative 7 squared is 49. Okay, so I'm going to have this 49 here. So I have 49 minus 4ac. So I put my 4 here, and my a is 2, and my c is 6. So now negative 4 times 2 times 6 is negative 48. So this in here is going to become 49 minus 48. And down here I have 2a. So since a is 2, if I do 2 times 2, I get 4. Okay, so let me rewrite this again. So I'll have 7 plus or minus the square root of 49 minus 48. So why is it 48? Well, remember, because we have negative 4 times 2 times 6, which gives us negative 48. Okay, and this is all over 4. All right, and so 49 minus 48 is 1. So I can rewrite this again as 7 plus or minus the square root of 1 all over 4. And the square root of 1 is just 1. So actually, I'm just going to write this. I'm going to write 7 plus or minus 1 all over 4. All right, so again, 49 minus 48 is 1. So I would have the square root of 1. And the square root of 1 is just 1. So that's why I have 7 plus or minus 1 all over 4. So this time, let me ignore the minus for a second, and I'm just going to do 7 plus 1 divided by 4. Okay, so what is 7 plus 1? 7 plus 1 is 8, and what is 8 divided by 4? 8 divided by 4 is 2. So we know that one solution here is x equals 2. Okay, so let me go back a step or two here, and this time we'll do it with minus. So we know that one solution is x equals 2, so let's do it with minus this time. So what is 7 minus 1? 7 minus 1 is 6. And what is 6 over 4? Well, 6 over 4 reduces to 3 over 2, right? Because I can divide 6 by 2, I get 3. I can divide 4 by 2, I get 2. So 6 over 4, again, reduces to 3 over 2. So I'll see that the solutions here are x equals 2 and x equals 3 over 2. So the next question says simplify the polynomial, and we see the problem on screen. So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So the strategy here is to divide each number by the smallest number. So what is the smallest number here? Well, the smallest number is 4. So let me divide everything by 4. So if I have 12 and I divide it by 4, I get 3. So I'm going to write 3x. And if I have 20 and I divide it by 4, then I get 5. All right, and I leave the minus sign like it is. So I have 3x minus 5, and 4 divided by 4 is just 1. So I end up with 3x minus 5. So again, the key here is just to divide each number by the smallest number in the polynomial, and that number was 4. So B is the correct answer here. Your next question is on the screen, simplify the polynomial. So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so the first move I'm going to make here is to divide everything by the smallest number. And the smallest number here is 5. So I'm just going to leave the x's alone for right now, and I'm going to divide each number by 5. So what is 15 divided by 5? 15 divided by 5 is 3. So I'll have 3x raised to the power of 4. And I want to put this minus sign here so I don't forget it. And if I do 10 divided by 5, 10 divided by 5 is 2. And I'm just going to leave the x right here. And if I do 5 divided by 5, 5 divided by 5 is 1. So I'll just get this x here. All right, so I now have 3x raised to the power of 4 minus 2x divided by x. So the next thing I want to do here is divide everything by x. Okay, so if I do that, here's what I'll get. So if I have 3x raised to the power of 4 and I divide by x, I'm going to get 3x raised to the power of 3. And again, I want to make sure I bring this minus sign along. All right, so if I divide 2x by x, the x's will cancel out. And this x down here also cancels out. So I get 3x raised to the power of 3 minus 2. Now, you might have been able to just start from the problem here, and you might have just seen that you could divide everything by 5x. And if you did that, then you probably skipped this step right here, and you probably just looked at this and were able to get this answer. And if you did that, great job. You can definitely do it that way. In fact, it's faster if you do it that way. But just to cover all of our bases here, I just wanted to show you that you could start by just dividing by the smallest number and then worry about the variable after that. So that's one way to do it. So again, C is the correct answer here. And I do have another video where I go over more examples of division with polynomials. So I'll put a link to that down below in the description if you're interested in seeing more examples of these types of questions. Which of the following is equivalent to x minus 5 over x plus 2x minus 1 over 2? So let me give you a chance now if you'd like to pause the video, take all the time you need with this, and whenever you're ready, we'll go over the answer. Okay, so the key to getting this right is to understand how to approach rational expressions. Now, you might be wondering, what is a rational expression? Well, a rational expression is a ratio of polynomials. Another way to say that is rational expressions are fractions with polynomials. So basically, rational expressions are fractions with polynomials. So in this case here, in order to solve this question, okay, we first have to get a common denominator. So whenever you add fractions, you always have to get a common denominator. So let me show you how I'm going to do that here. So let me look at my first fraction, this x minus 5 over x. So I'm going to start by looking at the first fraction, and I'm going to come over to the second fraction, and I'm going to see what I have in the denominator. So I look at my second fraction, and I see that there's a 2 in the denominator. So I come back to my first fraction, and I'm going to multiply both the top of the fraction and the bottom of the fraction by 2. So let me distribute the 2 here. So I'm going to do 2 times x and then 2 times negative 5. So that'll become 2x minus 10. And it's important to remember to take this minus into consideration here. So I'll have 2x minus 10 over 2x. Okay, so now I come over to my second fraction, this 2x minus 1 all over 2. And I have to remember that originally, before I had this 2 here, all I had in the denominator of the first fraction was an x. So I'm going to have to multiply both the top and the bottom of the second fraction by x. I'm going to take this x and I'm going to distribute it. So let me show you what I mean by that. So x times 2x becomes 2x squared. And remember, I have to remember to bring this minus along for the ride. So this will become minus x because x times 1 is just x, and I have to remember to keep this minus sign here. Now down here, 2 times x becomes 2x. So I now have 2x minus 10 over 2x plus 2x squared minus x over 2x. So the key now is to combine my like terms. So to combine like terms here, what I want to do is do 2x minus x. And if I do that, I'm just going to get positive x because 2 minus 1 is just 1. Okay, so when I rewrite this, I'm going to rearrange this now so that I have 2x squared plus x minus 10. And I write this all over 2x. Okay, so again, when I got to this step here, I had 2x minus 10 divided by 2x plus 2x squared minus x divided by 2x. So I want to look here for the like terms. So this 2 here has an x raised to the power of 1, and this minus x is x raised to the power of 1. So I can combine these like terms, so that's what I did. So 2x minus x just gave me positive x. All I did was I just rearranged this so that I wrote 2x squared first, then plus x minus 10, all over 2x. Whenever you do get that common denominator, all you want to do is just add the numerators, and you just leave that denominator as it is. So I know this is kind of confusing, and I know that if you haven't studied addition with fractions or looked at this stuff yet, this might be kind of confusing for you. All right, so hopefully this makes sense. If not, I would recommend just reviewing adding fractions, and I'm happy to link to a video where I cover that. And if you have any questions on this, let me know down below. But the correct answer here is C. The next question says, which of the following is equivalent to x minus 7 over x plus 3 times x plus 2 over x minus 6. So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So to get this right, we're going to rely on the FOIL method. Okay, so we're going to use the FOIL method. So I'm going to start with x minus 7 and x plus 2. So I'm going to apply the FOIL method to them. And then I'm going to go down to the bottom of the fraction, and I'm going to use the FOIL method with x plus 3 and x minus 6. All right, so let me show you what I mean. So let me start by just using the FOIL method again with x minus 7 and x plus 2. So what I want to do here is start by multiplying the first terms together. So x times x gives me x squared. So now let me do the outer terms. So the outer terms would be x and 2. So I multiply them together, I get 2x. So now let me work on the inner term. So I have this minus 7 and x here. I multiply them together, I get minus 7x. And then if I look at the last terms here, the last terms would be the minus 7 and positive 2. So minus 7 times positive 2 is minus 14. So now what I want to do is combine the like terms. So my like terms are my 2x and 7x. So what is 2x minus 7x? 2x minus 7x is negative 5x. So the top part of the fraction is going to become x squared minus 5x minus 14. So now let's do the FOIL method on the bottom part of the fraction. So in other words, let's do x plus 3 times x minus 6. X times x gives me x squared, and the outer terms would be x times minus 6, which is going to give me minus 6x, or negative 6x, however you want to say it. Then the inner terms would be this 3 and the x. So 3 times x is plus 3x, all right, positive 3x. Then the last terms would be the 3 and negative 6, which is negative 18. So I combine my like terms, and doing that gives me x squared minus 3x minus 18. All right, so the correct answer here is A, and the trick was to just FOIL the top and the bottom of the fraction. So there's one last point I want to make here, and that's how would you handle this if instead of multiplication, this was a division question? Well, here's how you would do it. So if this was a division question and they changed this multiplication sign into a division sign, the way that I would set it up is I would leave the first fraction exactly the same. So the x minus 7 over x plus 3, I'd leave that exactly like it is. But what I would do is take this x plus 2 over x minus 6, I'd flip that upside down, and I'd turn this into a multiplication sign. So I would put the x minus 6 right here, and the x plus 2 down here. Then I would just use the FOIL method for the top and then for the bottom like I just showed you, and that would get you the correct answer if the question had been division. So now let's talk about system of equations. So some textbooks call these systems of linear equations, some say simultaneous equations. I just say system of equations. So basically on screen here, I have a pretty standard example of a system of equations question, and the wording might be different on the test depending on how they word the question on your test, but this is a pretty standard example here I want to cover. And I didn't write out multiple choice answers for this, so this is just for you to come up with the answer on your own here. And the answer, really there's two answers here. I want you to find the x and y values for the following system. And if you're not sure how to do this, absolutely no worries. This is a challenging topic and we're just going to go over it either way. So let me give you a chance now, if you'd like to pause the video, try this out, and whenever you're ready, just unpause the video and we'll talk about it. So I think one thing that makes these questions challenging sometimes is that there are multiple ways to approach them. And I'm going to show you the substitution method here first. And I'm going to call this 2x plus y equals 2 equation 1. And I'm going to call this 5x plus 4y equals 20 equation 2. Now, what I want to do is pick one of these equations, and I want to pick one equation and solve it for a variable. And that's how I'm going to start doing this. And this is where this can get a little bit confusing because there's not just one right way to do this. There's several ways I could do this. But in my opinion, the easiest way to do it in this case is to start with equation 1 and solve it for y. Now, why do I say that that's probably the easiest way to do it? Well, I say that because if I look at y, I don't see a number in front of it. All right, so whenever I see that everything else, like this x has a 5 in front of it, this y has a 4 in front of it, this x has a 2 in front of it, but when I see this y, there's nothing in front of it. So I think, in my opinion, it's going to be the easiest to take equation 1 and solve it for y. So that's how I'm going to start this off here. And if you're not sure what I mean by that, when I say solve this equation for y, all you have to do is get y by itself on one side of the equation. And we're going to do that here by subtracting 2x from both sides. So all I'm doing here is taking equation 1 and I'm going to solve it for y. So I get y equals 2 minus 2x. So I have my y equals 2 minus 2x here. So now what I'm going to do is I'm going to come down here into my second equation. And where I see a y, what I'm going to do is take this 2 minus 2x and I'm going to plug it into the equation here for y. So if you're not sure what I mean by that, let me show you here. So I'm going to take equation 2 and I'm going to rewrite it. So I have 5x plus 4y. But instead of just writing y, this y letter out, I'm going to write 2 minus 2x. And this equals 20. Okay, so let me distribute this 4 now. So 4 times 2 is 8. 4 times negative 2 is negative 8. So this will become 5x plus 8 minus 8x equals 20. So now what I'm trying to do is solve this equation for x. Okay, so if I combine the like terms, if I do 5x minus 8x, I'll get negative 3x. And if I subtract, so let me do that. And if I subtract 8 from both sides, I'll get 12. So 3x equals 12. Actually, no, this is negative 3. So it should be negative 3x equals 12. Now let me back up here a second and explain how I got that again. So what I did was I got to this step 5x plus 8 minus 8x equals 20. So what I'm going to do is I'm going to do 5x minus 8x. That's how I got the negative 3x. And then I subtracted 8 from both sides. So 20 minus 8 is 12. So that's how I got this negative 3x equals 12. And I ran out of room here at the bottom of the screen. That's why I didn't show all the steps out. So now what I want to do is divide by negative 3 on both sides of the equation. So I divide by negative 3, and I get x equals negative 4. So now what I'm going to do is I'm going to come back up here to this equation, this y equals 2 minus 2x, and I'm going to take the negative 4 and plug it in here for x. So let me do that up here where I have more room. So again, I take the equation that I solved for y, and what I'm going to do is I'm going to plug negative 4 in for x. So I'd rewrite this as 2 minus 2 times negative 4. So this is going to become 2, this really turns into 2 plus 8, because negative 2 times negative 4 becomes positive 8. 2 plus 8 is 10, so y equals 10. So my two answers here are y equals 10 and x equals negative 4. So we know that the answers are x equals negative 4 and y equals 10. Now let me back up here and let me just show you a different way that you could have done this. And some textbooks call this linear combination. I like to call it the cancellation method. You can also call it stacking. So there's different words for this. Basically, what I want to do here is set this up so that terms will cancel out. So what I'm going to do here, since I see that this y doesn't have anything in front of it, but I see that the y in equation 2 has a 4 in front of it. So what I'm going to do is I'm going to take the entire equation 1 and I'm going to multiply it all by -4. So I want to multiply this all by -4. And let me show you what happens when I do that. So if I multiply everything in this equation by -4, this will become -8x minus 4y equals -8. So now what we're going to do is we're going to add the equations up. So I have them stacked on top of each other and we're just going to add them. So what is -8 plus 5? -8 plus 5 is -3, and I pull that x along for the ride. Now -4y plus 4y, these are going to cancel out, which is what we want. And -8 plus 12 is, -8 plus 20 is 12. So we just get down to this, -3x equals 12. And if I divide both sides by -3, I realize that x equals -4. Okay, so this is a different way to do this because I would get x equals -4. And then all I would have to do is come back and I would have to take one of these equations, solve it for y, plug -4 in for x, and that would tell me what y equals. So this is just another way to do it, and you might notice that this seems like it's a lot faster, and it can be, especially if you know how to do this method, this cancellation, linear combination, whatever you want to call it. If you get some practice doing this method, it can be a lot faster, but it's up to you to decide how you want to do these on your test. So your next question is on screen. It says, what are the x and y values for the following system? So let me give you a chance now if you'd like to pause the video, try to figure this out, and if you get stuck, no worries, because we're just going to go over the answer. Okay, so let's talk about this question. So first, let me start by going over it using substitution, the substitution method. So I'm going to call the 6x plus 5y equals 30 equation 1, and the 3x plus 5y equals 35, let me call that equation 2. So the key here when you use substitution is you want to pick one equation and you want to first solve that equation for a variable, and that's going to give you your starting point to figuring out the answers. So I know that sounds kind of confusing, so let me show you what I mean. So let me start off by picking equation 1 here, and let's solve it for y. So I'm going to start with equation 1 and I'm going to solve it for y. Now know that I don't have to start it that way. I could pick equation 1 and solve it for x. I could also start by coming down to equation 2 and saying, hey, I want to solve equation 2 for x. And you could do it that way. All right, so there's different ways to do these questions. That's why it can be kind of confusing when you're learning how to do these. It could be kind of confusing for me actually to teach these because there are different ways to approach them. But what I'm doing here is I'm starting with equation 1 and I'm going to solve it for y. So let me subtract both sides of equation 1 by 6x. So that gives me 5y equals 30 minus 6x. So now what I want to do is divide both sides by 5. So when I do that, I get y equals 30 minus 6x over 5. And I'm just going to leave it like this. So now let me come down to equation 2. And for equation 2, where it says y right here, I'm going to replace this y with 30 minus 6x over 5. So again, I'm just going to come down to equation 2, and I'm going to plug in 30 minus 6x over 5 in place of y. So that's all I'm doing. So what I see right away here is that I can actually cancel these 5's out because 5 divided by 5 is 1. So that actually makes this a bit easier to work with. So I'll now have 3x plus 30 minus 6x equals 35. And the name of the game now is to get x by itself. So what is 3x minus 6x? 3x minus 6x is negative 3x. And what is 30 minus 35? 30 minus 35 is positive 5. So I'm just going to take this 3x plus 30 minus 6x equals 35, and I'm going to solve it for x. And to do that, again, I want to subtract 30 from both sides. That's how I got this 5 here. And I want to do 3x minus 6x, which gives me negative 3x equals 5. And we almost have x by itself. What we need to do here to finish this is divide by negative 3 on both sides. Okay, so what we've learned is that x equals negative 5 over 3. So now there's a couple ways I could do this. So I could take this x equals negative 5 over 3, and I could come over here to the equation that I've already solved for y, and I could plug this right in here for x and solve it for y that way. Or I could come back to one of the equations here, and I could plug x equals negative 5, 3 into one of these equations. And so actually what I'm going to do is I'm going to come down to equation 2, and I'm going to plug x in for, I'm going to plug in negative 5 over 3 for x right here. Now, you might be wondering, why did I do it this way? Well, first of all, I didn't have to do it this way. There's other ways I could have done this. But the reason I'm doing this is because I see that the 3's are going to cancel out if I do it this way, which makes this, I think, fairly easy to do. So basically, if I do it this way, again, what happens is the 3's will cancel out. I'll be left with negative 5 plus 5y equals 35. So let's add 5 to both sides. All right, so if I add 5 to both sides, I get 5y equals 40. And so now I have to divide both sides by y. So if I do that, I figure out that y equals 8. All right, so my answers are x equals negative 5 over 3 and y equals 8. Let me just back up here a second in case this was confusing. Basically, once I figured out that x equals negative 3 over 5, I had a couple different options to get y. The first option could have been to take this equation here that I solved for y already and just plug in negative 5 over 3 in for x. And if I do that and do the math, I'll get y, and I'll get the same answer, y equals 8. I could have also came back to equation 1, and I could have equation 1 before I solved it for y, just the equation 1 that we originally had here. And I could have plugged negative 5 over 3 into this equation for x. If I did the math and solved it for y, I also would have got 8. What I chose to do was come down to equation 2, where it says 3x plus 5y equals 35, and I chose to plug negative 5 over 3 in for x into equation 2. The reason I did that was because I saw that the 3's would cancel out, giving me negative 5 plus 5y equals 35. And these types of questions, if you use the substitution method, you'll get the right answer that way, but you just have to take your time with it. So now let me show you how to do this using what I call cancellation. Again, other textbooks call this different things, but the point here is that I want to set this up so that two terms will cancel out. And so what I'm going to do here, I think the easiest way to do it is to look at this equation 1 here and multiply everything by negative 1. So I'm going to take this entire equation here and I'm going to multiply it by negative 1. All right, so let me show you what happens if I do that. So if I do negative 1 times 6x, that becomes negative 6x. Negative 1 times 5y is going to become negative 5y. And 30 times negative 1 becomes negative 30. So I'd have negative 6x minus 5y equals 30. So now let me take the 3x plus 5y equals 35 and write that down below. So now I'm just going to stack the equations on top of each other, which I did, and add them. So negative 6x plus 3x, that becomes negative 3x. Negative 5y plus 5y cancels out, which is what we want. Negative 30 plus 35 becomes positive 5. And if I divide by negative 3 on both sides, I see that x equals negative 5 over 3. So I'd get that x equals negative 5 over 3, and then I would just want to come back here to one of the equations, and I'd want to plug negative 5 over 3 in for x, do the math, and get y. So let me show you that. So let me try this time. Let me pick equation 1. So my 6x plus 5y equals 30. Let me do that this time because I already showed you what would happen if I plugged negative 5 over 3 into this equation 2 here. So let me do 6 times negative 5 over 3 plus 5y equals 30. So what's going to happen here if I do it this way? Well, 6 divided by 3 is 2. All right, 2 times negative 5 is negative 10. So I'd have negative 10 plus 5y equals 30. And I'd want to add 10 to both sides. So I add 10 to both sides, I'll have 5y equals 40. Now I divide both sides by 5 to find that y equals 8. So however you did this question here, x equals negative 5 over 3 and y equals 8. If you got this right, however you did it, really great job. If you didn't get this right, great job for trying. This is not an easy question. So let's switch gears now and talk about functions. Now, over my years of making GED videos, I know that several people have asked about functions, so I know this can be a tricky topic. So what I want to do here is show you how to get some of the more common types of function questions right, should these show up on your test. And I think that an example like this one on screen is a good starting place for functions. And the reason I think that is because if you look at the math study guide put out by the GED testing service, they have an example that's similar to this one. So that's why I want to start here as we talk about functions. And I will put a link down below in the description to my video where I walk through the study guide put out by the GED testing service for math if you're interested in that. But anyway, the first thing to know about functions is that a function relates an input to an output. Now, the set of all possible values that we can use as inputs is called the domain. And the set of all possible values that can be outputs is called the range. And every member of the domain must correspond with exactly one member of the range. Another way to think about that is that for a function, each input has exactly one output. Now, for the tables down below, the x's here, the numbers beneath this x, represent the inputs, and the y's, the numbers beneath this y right here, represent the outputs. Now you might be wondering, inputs, outputs, domain, range, what does this all mean? I just want to get more questions right on my test so I can pass faster or get my goal score faster. So what I want to tell you is the most important thing, how to beat these questions, should you get something like this on your test. So basically, the strategy is that you want to look for each answer choice, look at the numbers underneath the x and see if any of them show up twice. So I see that -2 only shows up once, -1 only shows up once, and -3 and -3 show up twice. So what I want to do now is check the output for each -3. And if the numbers are different, then we know that a is not a function. So here we have -3 as an input and 2 as an output. Here we have -3 as an input and 9 as an output. So these two numbers, 2 and 9, are different, so this can't be a function. All right, because remember, each input has to have exactly one output or it's not a function. So let's look at B now and let's do the same thing. So the strategy again is to start by looking at all of the numbers under the first column. So we want to start by looking at the numbers underneath the x. And we want to see if any of them show up more than once. So 7 shows up once, -7 shows up once, but we have two -1s. So for each -1, we want to check the output. So this -1 has 9 as an output, and this -1 has 92 as an output. So since the outputs are different, this is not a function. Okay, so let's come over here now to C. So for C, we're going to apply the same strategy. So let's look and see if any of the numbers under x match. So we've got 1, we've got 2, we've got 3, we've got -2. So actually C looks like it's a function because every single input has exactly one output. So again, each input has to have exactly one output or else it's not a function. Now you might be saying, well, there's two 8s here. So if the outputs are the same, that's fine. We don't care if the outputs are the same. What we care about is making sure each input has exactly one output. If you wanted to check answer choice D, you'd apply the same strategy. So look at the numbers underneath the x here and see if any of them show up twice. So 1 shows up twice. So what I want to do is for each one, I want to check the output. So this one has 2 as an output, and this one has 14 as an output. So is D a function? Well, D is not a function because for this to be a function, each input has to have exactly one output. So if two inputs have different outputs, it can't be a function. So D would be out. All right, so hopefully this makes sense. C is the correct answer here. So let's talk now about the vertical line test. And for the next few examples, I'm only going to give you two different multiple choice answer choices, A, yes, B, no, since we're just practicing right here. And basically, the idea with the vertical line test is that you can look at a graph and tell if it's a function or not by drawing vertical lines. And if you draw a vertical line and it touches the graph more than once, then we know it's not a function. And if you draw a vertical line and it only touches the function once, then you know that it is a function. And sometimes it can help to draw multiple lines if it's hard to see with just one. But anyway, let me give you a chance now to pause the video and try to answer if this is a function or not, yes or no. And if you get stuck or aren't sure how to do it, don't worry because we're just going to go over it and then we're going to look at more examples. Okay, so the idea here with the vertical line test is that I want to just draw a vertical line, a line going up and down. And I want to see if I just draw this line going up and down, does it touch the graph more than once? No, in this case, it only touches the graph once. So since the line only touches the graph once, the answer is A, yes, this graph represents a function. So here's the next example. Does the graph represent a function? A, yes, or B, no? Let me give you a chance now to pause the video, try this one out, and if you get stuck or aren't sure how to do it, don't worry about it because we're just going to go over the answer. Okay, so the idea here is that if a vertical line touches the graph more than once, we know it's not a function. So let me start by drawing a vertical line, and I draw my line, and I see that the line touches the graph twice, right? So the line touches the graph right here, and it also touches the graph right here. So if a vertical line touches the graph more than once, we know it's not a function. This vertical line touched the graph twice, so we know this is not a function. So the answer here is B, no. So remember, if a vertical line touches the graph more than once, it's not a function. Does the graph represent a function? So let me give you a chance now to pause the video, try to figure this out, take all the time you need, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so just a general reminder with this question, and really for every question in this video, the most important thing right now is the learning. So if you weren't sure how to do this, or if you got the question wrong, absolutely no worries. The most important thing right now is the learning. It's not whether we get the questions right or wrong. So with that being said, the first point that I want to make here as we cover this example is that if a vertical line touches the graph more than once, we know it's not a function. And if a vertical line touches the graph once, we know it is a function. But in order to get this question right, we also have to remember to take into consideration the entire graph. And that's really why I included this example here, is just to make the point that we have to consider the entire graph. Because if we just do the vertical line test on part of the graph, you might look at this and think it's a function. So if I draw a vertical line right here, and know that I am intending to make these lines straight up and down, but my computer, or maybe it's just my drawing skills, are making them not look straight up and down, but just pretend that this line went straight up and down because that's my intention. If we draw a vertical line right here, it'd be easy to say, well, the vertical line only touches the graph once, so this is a function. But the problem with that is that we're not considering the entire graph, because if I draw the vertical line right here, what we see is that right here, the vertical line touches the graph more than once. So the answer is B, no, this is not a function. So remember, if a vertical line touches the graph more than once, we know it's not a function. And just remember too that we have to take the entire graph into consideration. Because if all we did was do the vertical line test right here, or even here, if we did the vertical line test right here, it'd be easy to come away from this and think this is a function. But the problem with that is that we didn't take the whole graph into consideration. Because if we considered maybe right here or right here, we would see that the vertical line touches the graph more than once. So the two takeaways here are, number one, if a vertical line touches the graph more than once, we know it's not a function. And two, just remember to take the whole graph into consideration, because if you just look at a part of it, it can be misleading. So here's your next example. Does the graph below represent a function? So now's your chance, if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So remember, to figure out if a graph represents a function, we can use the vertical line test. Now, if a vertical line touches the graph more than once, we know it's not a function. And if a vertical line touches the graph just once, we know it is a function. So in this case, if I just draw my vertical line, I see that the vertical line touches the graph more than once, right? It's going to touch here and it's going to touch down here. So in this case, the answer is B, no. Because if a vertical line touches the graph more than once, we know it's not a function. This question says, which function below could represent the function in the table above? So now's your chance, if you'd like to pause the video, try to figure this out, and whenever you're ready, just unpause the video, and whether you get it right or wrong, whether you have trouble with this or not, we'll go over it. So as I walk us through this, I'm going to go answer choice by answer choice and just use process of elimination until we find the correct answer. And I'm going to start by evaluating answer choice A. So what I'm really interested in is this 9x minus 2 portion. So what I'm going to do is I'm going to test 1 for x, and I'm going to see if I plug 1 in for x, if I get 11, we'll keep going. If I don't get 11, then we'll know that we can rule out answer choice A. So basically, again, I'm going to take 9x minus 2, and I'm going to plug 1 in for x. And if I get 11, then we're on the right track. If I don't get 11, then we know that A is not the right answer. So 9 times 1 is just 9. 9 minus 2 is 7. So I didn't get 11 here, so I'm just going to take answer choice A out. So we can completely eliminate answer choice A. So now let's evaluate answer choice B. And to evaluate B, the part that I really am concerned with is the 10x plus 1. So I'm going to start by plugging 1 in for x. So when I rewrite this, I'll have 10 times 1 plus 1. So 10 times 1 is just 10 plus 1 is 11. Okay, so when I plug 1 in for x, I see that the output is 11. So we could be on the right track here. So let's keep going. So let me take the 10x plus 1, and this time I'm going to plug 2 in for x. So I have 10 times 2 plus 1. And the name of the game here is that I want to do the math and see if I get 16. If I get 16, then we'll keep going. If I don't get 16, then we'll take B out and we'll eliminate the answer choice. So what is 10 times 2? 10 times 2 is 20. 20 plus 1 is 21. So we didn't get 16, so I can rule answer choice B out. So answer choice C, 5x plus 6 is what I'm going to test next. So 5x plus 6, I want to start by plugging 1 in for x here. And I'm going to see if I end up with 11. So what is 5 times 1? 5 times 1 is 5, plus 6 is 11. So far so good. So let's test 2. So I want to take 5x plus 6, and this time I'm going to plug 2 in for x, and we'll do the math, and we'll see what we get. So 5 times 2 is 10. 10 plus 6 is 16. So far so good. So now let's come down here and let's test 3. So what we can do is we'll take 5x plus 6 and we'll plug in 3 for x, and we'll do the math, and we'll see if we get 21. So 5 times 3 is 15. 15 plus 6 is 21. All right, so this is looking like the correct answer choice, but let's just test 4. So 5, this time we're going to do 5 times 4 plus 6. So 5 times 4 is 20. 20 plus 6 is 26. So C is the correct answer here. So the next question is on the screen. Let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so in this case, instead of F, we see H. This could also be a G. It doesn't really matter. The process for solving this question would be the same whether this was an F or a G, but here we just have an H. And what we want to do here is we want to focus on this x cubed plus 7x minus 11 portion. And when I say x cubed, that's just another way of saying x raised to the power of 3. So we want to focus on this portion right here, and we're going to take 2, and we're going to plug 2 in for x. So let me replace the x's here with 2's, and let me rewrite it. So 2 raised to the power of 3 equals 8, and 17 times 2 is equal to 34. And when I do 8 plus 34 minus 11 in my calculator, I get 31. And B is the correct answer here.